if you store it to the drive, if you do it in the console.app, it'll say user private login. And so by default, all the string parameters that are substituted in automatically get turned to private unless you override it. So developers being lazy, they're not going to specify public-private unless they care about, so most of the strings that they log, they'll be able to see in their debugger, but they won't get logged to the hard drive. And that's Apple's design, but it's bad from a forensics point of view. If you really care about this a lot, there's this guy called the Eclectic Light Company. He's like a photographer, but he's also really interested in digital forensics. He lives in the UK, and he writes these incredibly good blog entries. And he also distributes software, which you can download and run. He has this log analysis program that will grab lots of the log files and allow you to view them with searching and with logical expressions. And this is a really good segue. It turns out that if you want to do forensics on the Mac, you can't get by with just the commercial tools. You really have to be using the open source tools also, because there's just not enough coverage by the commercial tools. And this is a bar graph that the tool makes showing you how many log entries does it have for different times of the day. So that I'll talk a little bit. Any questions before I go on to talking about the tools that are available? Yes, in the back.
Yes, so with the log compression and consolidation.
I can't hear what you're saying.
With the log compression and consolidation, I have a question for how long log entries last. Are they just kind of there indefinitely, or?
I don't have a good answer for how long logs last. They seem to last a long time. The machines we had at George Mason had not expired their logs after 6 months. And as I mentioned, the FS events-d seems to never expire. So it does seem that Apple is not really paying attention to rolling over these very, very efficient log formats. So let's talk a little bit about the forensic tools. So built-in tools, Apple has this tool called SysDiagnose. If you ever called up Apple and saying, I'm having problems, they say, oh, well, could you run this diagnostic tool for us and then upload it? And so SysDiagnose, what it does is it runs like 50 to 100 different tools. It puts all the results into a tar file, and then it optionally uploads it to Apple servers. But you can also run it yourself and diagnose it yourself. And you can actually, if you type like Shift, Control, Option, Apple, dot, it will run it. But you can also run it on the iOS devices too, and on tvOS. It tells you like all the running processes. It captures the log files. It captures things about the file system. It's the output's really big. So here is the output. It gives you a full timestamp, and here it's a tar.gz file that is 26 megabytes in size. So I guess that compresses to about 100 megabytes of collected forensic information about a person's Mac. So if you can only run one command on somebody's machine, that's the command to run. On my system, it was 1,349 files that it captured. And not all of these are privacy invasive, but like it has all information on every Wi-Fi access point that you've associated to, stuff like that. There's a program they give you called SpinDump, which tells you all the running processes and all the threads in those processes and where in the stack each thread is. It's a real good snapshot of what the system is doing. But there's like these open source tools. So volatility is the go-to tool for doing memory analysis. On the Mac, it's a bit harder to use because volatility has to be compiled for the. You have to have a profile for the kernel that you are using. And to make that kernel on the Mac, you need to have an Apple release kernel with debug symbols. And for the students in the class, they had debug symbols for some of the kernels, but not others. Turns out that there's a company called Velexity that the people who do volatility do on the side. The commercial version of volatility has all the profiles. The commercial version of volatility also can get the memory from a running system. It's very hard to capture the RAM on a running Mac. there are commercial tools available and you should use one of them. For my class, it turned out that the best way of getting people to capture memory was to run Mac OS in a virtual machine and suspend the virtual machine and take the memory file. So here's some other tools that are out there. There's a program called Apollo, the Apple Pattern of Lazy Outputter. It's a lot of Python scripts that go after those SQL-like databases and print summary reports that are read into an Excel spreadsheet. Mac Apt, the artifact parsing tool, does something similar. There's OS X Auditor, OS X Ripper. Largely, these are turning the Apple databases into text files that you can analyze with other tools. As I mentioned, parts of the file system are restricted from the user. If you want to use these tools on a live system, you have to go into security and privacy, full disk access, and give terminal access to the whole drive. Otherwise, programs run from the terminal can't access all the good databases. And here are these tools. So then there's some commercial tools. So for disk imaging, you can actually image these encrypted drives. If you know the password, you put the drive in target mode, it asks you for the password, and then you can image the drive. You better do that in the machine that made it. If you take it and put the SSD on another machine, you can't image it. Blacklight is a forensic analysis tool made by a company called Blackbag. This is probably one of the nicest forensic analysis tools on the market. It's much easier to use than Encase. And it will analyze Windows, Android, iPhone, and Mac OS X machines. And it costs like $1,000 a year for a renewable license. It's slightly restricted access, so it's not that easy for individuals to buy, but individuals can buy it if they send a convincing email message. Macquisition is their acquisition tool. It will grab RAM, it will grab the disk, it will deal with fusion drives. This company, they do actually a lot of reverse engineering, a lot of decompiling of the Apple code to actually figure out what's going on. And they do have a software-based write blocking tool if you want to run Macquisition from another Mac. Elcomsoft is a Russian company that has some really good password cracking tools. They will crack the Mac OS X keychain. It's significantly better than John the Ripper, and it will run in a network mode, so you can have every computer in your law firm or police station or on your cluster running this. I recommend not running it on systems connected to the internet, just by policy. But you have to have a good password database for doing the cracking. And this is from the Elcomsoft website. They're showing you that this is the number of password guesses you can do per second. With OpenOffice on a machine with an NVIDIA card, they can guess 530,000 passwords per second on OpenOffice, but they can only guess 22,000 per second on Microsoft Office 2010 because this is much more computationally difficult to do each guess. And so if you're going here, you can try all combinations. You don't need a good password dictionary. If you're working here, you need a good password dictionary. And this also shows you the acceleration that you get having specialized hardware like the GPUs. If you have an Intel Xenon E5 2603, you'll only get 500 guesses per second on this Microsoft Office file format. But if you have this NVIDIA GeForce GTX 980, you can get 22,000 per second. And that's because the NVIDIA machines are just much better at password guessing than the Microsoft hardware. Any questions about this?
So how come NVIDIA performance is better on OpenOffice than IBM?
So I don't know, but I would guess that the specific encryption key generation thing that they're using works. There's code for that NVIDIA that's a little more efficient. That's my guess. So, you can just take C code and compile it with CUDA code, but you can also hand tune it. And if you're selling something and publishing graphs like this, you're better off hand tuning it. And so it's probably going to be different hand tuned for the different GPUs. So Blackbag also has an Apple iCloud production service, which I didn't know about. They say, have you worked with Apple on a legal process? Make sure you reveal all the data using our new iCloud processing service. Once processed, bring together iCloud production set, mobile devices, and desktop images in Blackbag. So basically, Blackbag will help you deal with Apple if you are law enforcement. There's actually details on the Apple website if you're law enforcement, how to serve them with a discovery request or production request, not discovery. And they'll give you this data, and if you go over it without really knowing your way around it, you'll get like 5 to 10% of the data out. But if you know how to use the Blacklight tools, you can get out a lot more data. And they also have a service where they will help you get the data out. And that's a fee service, and they have a nice little video blog on it, which apparently very few people know about, because when I did this, it only had 537 views. Wow. Right? So Apple really goes out of its way to help law enforcement, but it's very quiet about it, because they don't want to have the reputation of being the company that goes out of its way to help law enforcement. So Apple, this is from the blog, Apple responds to lawful and legal requests. Apple has a document on their website for assisting you in producing requests. The results may be encrypted and or compressed. Many organizations receiving iCloud productions don't know how to view it, and 85% of the data can be missed, but it can be imported directly into Blacklight. So Blacklight actually understands the file format that Apple uses, of course, and it imports everything and decompresses it and does whatever. The people at Blacklight say this has been used in child exploitation cases with positive results. So I'm at 8 o'clock. I have some references. This is an amazing book. It's like 1,000 pages long. It was published in 2000, 1,600 pages long, and it talks about open firmware and keychain and kernel startup and interprocess communication and lots of the file systems. And that's as far as it went until in 2007. Then this guy, Jonathan Levin, who is a forensics practitioner, but he's also a crazy reverse assembler. He's written 3 volumes, OS X Internals Volume 1. And this basically starts where the other one leaves off. It talks about all the different operating systems and the minor ways in which they are different. It talks about the Mach-O format, the dynamic loading of libraries and how to hook it if you want to write your own malware, which I'm sure he doesn't do. All the details of debugging and process tracing. And he has a volume 3, which is security, where he talks about the whole, defensive techniques and vulnerabilities and exploitation. And in this section, part 2, he actually goes through, it's for Star OS, which means it's for Mac OS, tvOS, iOS. So he actually goes through practically every significant hack on the OS, on the iPhone, and explains how that hack worked. And at the assembly language level. So then there's this book, which is Advanced Apple Debugging Reverse Engineering, and this tells you how to use LLDB, Python, and dtrace, which is pretty cool. And then I have a web page where I have a lot more references. So I think that's all. Thank you. Any other questions? So I got mostly done in 90 minutes, so thanks again.
Thank you, Simpson. On behalf of the ISSA chapter, I want to present a small token of appreciation for coming out and presenting for tonight.
Thank you.
So thank you very much.
Great.
A couple of small announcements, especially for people that walked in after Simpson started speaking. Alex, can you put
have it back up.
CPE, sir. So coming up on the screen, if you want CPE credits, please use your phone, scan that QR code, fill that out tonight, because after 10 o'clock tonight, If you haven't done that, you do not get credit for CPEs. So please go ahead, and if you haven't done this already, this is our sign-in sheet. We no longer have a paper-based one. This is what we are using from now on. It's been working very, very, very well. Again, thank you for coming out. Please, I think there's more pizza out there. Please take some. Please get rid of your trash in the trash can, receptacles out there. And again, stay tuned on our website. Look out for emails as to July and August. Again, we're still figuring out exactly what we're going to be doing, where we're going to be doing it. So stay tuned. Best place is on the website. Again, thank you for coming out. I'll be around if you have any questions, and I know other board members will be around as well. So thank you.